Good morning once again. Today we're going to continue our discussion on ARIMA. So let's have a quick review of what we did last time. Okay, this is the file that we used. We said that for a time series, where a time series is different from cross-sectional data or panel data. A time series focuses on one unit, one individual, whose attributes are taken across several points in time. So for example, Philippines, we're taking a look at the GDP, GNP, unemployment rate, etc. And then we look at this for across different points in time, 1970 up to 2022. That's a time series. Okay, if you were looking at several units or several individuals at several points in time, and you know that's a panel data, the Philippines, Singapore, Malaysia, etc. We're looking at their GDP, GNP, etc. 1970 hanggang 2022, panel data yun. Sabi natin, yung panel data can be balanced or unbalanced. Pag balanced, lahat ng individuals, lahat ng countries in that example, present sila across several time, across a different time frames. Ngayon, pag nagbabago yung composition ng units, unbalanced na yun. So kunyari, 1970, wala naman si Philippines. 1971, wala pa rin siya. 1972, andun na siya. Then that's an example of an unbalanced data. Okay, so for a time series, there are different ways to model time series. No? So many. But one of the most popular one is the Box-Jenkins approach. Yung Box-Jenkins approach, aka ARIMA, Autoregressive Integrated Moving Average. So last time we said that the AR component there, it's a ARIMA, yung AR component is autoregressive, which means that you're using the values of the time series itself, yung past values niya, in order to predict or to model the future. Okay, so for example, y sub t is equal to a certain constant alpha 1 times y sub t minus 1. So ganun yung ano niya, no? Ganun yung structure niya. So we're using the past value of itself. MA stands for moving average. So this is using the past error terms. And I means integrated. Ibig sabihin, okay, we have to transform the data first before we can use the AR-MA method. Okay, so I there stands for integrated, which means you have to difference the data. No? Bakit i-difference? Kasi hindi stationary yung data. Okay, so last time we said that an AR1 component has this structure. So AR1 to, no? Kasi the time series y sub t is modeled by its lag1, LAG, no? lag1. Let me write that lag1. Okay, lag1 siya. Ibig sabihin yung past one value. I'm sorry, hindi ko na-convert into LaTeX. Ano? It would have been better kung nakita natin siya as LaTeX. Pakita ko lang yun. No? Why don't I do it? You know how to do LaTeX naman, di ba? Diniscuss natin yan. Shift, okay, $, Y. Copy ko to. C. Ito pwede na. Okay. So yan yung natin, di ba? Ito yung model natin. Y sub t is equal to A sub O plus A sub 1 times Y sub t minus 1 plus epsilon sub t. So we are predicting or we are modeling our time series Y sub t using its past values. Ito, Y sub t minus 1. Yung lag 1 niya. Yung value yesterday, yung value last year, depending on the time frame. Okay? So, paki-chat nga please kung clear yung AR process. No? Paki-chat please kung clear yung AR. Dun sa ARIMA process, kung clear yung AR. Kapag sinabi natin AR, auto means self, no? Auto-regressive. So we are using the past value of the series itself. Okay? So in case you want to write this in your R, chat ko to para hindi yun na i-ano. Okay, thank you. Thank you guys for the feedback. Okay, you may wish to copy that in your R so that you have this, diba? Itong equation na to. Mas maganda kasi pag ganito kaysa yung AR1 component lang. Okay, good. Thank you, class, for your feedback. I appreciate that. All right, then we have also the, okay, now ito, take note of this, no? Lagyan lang natin to. Just for you to know, importante din to sa finance kasi dapat clear sa atin yung concept ng random walk. No? Lagyan na lang din natin. Sinusulat ko lang, sorry guys. Okay, so there is this equation, take a look at this. Y sub t is equal to y sub t minus 1 plus epsilon sub t. Okay, now this is not an AR process. Ito. Walang coefficient si A sub 1. In fact, ang coefficient ka pala 1. No? 1 times y sub t minus 1. Now that is not an AR process. Ang tawag dyan, random walk. Okay? And random walk ang tawag dyan. It's not an AR process. Anong difference niya? Yung AI1 itong random walk. Okay? If you take a look at the coefficient of y sub t minus 1, yung log 1, it's equal to 1. Okay? So hindi siya yung AR process, hindi AR1 process. Okay, and then so continuing, AR2, alam natin, no? AR2 log ng 2, no? So hindi lang y sub t minus 1, pati y sub t minus 2. AR2 process yun. So generally an ARP process, okay, we use the P lags sa ARIMA, no? Sa naman sa MA, we call it Q. So PQ. Alright? So ARP is y sub t. Okay. I should have sorry guys. Okay, then wag na lang. We're in the interest of time. Anyway, alam nyo na gawin yung equation dyan. So I would that you convert it into equation like this para mas kita. Okay, so sa P, ARP process, class, ano yung distinction niya? You have ito, A sub P times Y sub P. So log P, P logs. No? So we have here P minus 1 and T minus P minus 1. Okay, mali ito. No? Y sub T minus 1 minus 1. Kaya mas maganda dito yung talaga naka-LaTeX. No? Sorry guys, medyo parang na-OC ako na gawin ko tong ano para mas kita natin. I'm sorry about this. So, gawin natin okay. Brackets to. Para mas ano siya, mas pronounced. Underscore y sub t minus 2. Pag hindi kasi siya naka-latex, hindi masyadong clear yung ano yung equation. Pag naka-latex siya, clear na clear. Okay. Okay, so this is an AR1 process, no? Just to be consistent. Okay. Sinend ko na sa inyo para ano, you may wish to copy that. No? All right. So this is the ARP process, autoregressive at P lags. No? Y sub t is equal to a certain constant, intercept, plus yung component ni lag 1, coefficient ni lag 2, lag 3, up to yung lag P minus 1, okay, and then lag P. Alright, P lags, no? So, kunyari, contento, so this is A9 times Y sub T minus 9, and then A sub 10 times Y sub 10. Okay, mali ito. Dapat T minus 3. Tapos ito, YP. Log 1, log 2, log P. Okay. And log P, no? Log P lahat. A sub P times Y sub T minus P. All right, so that's the AR process. Okay, so Control C. Baka hindi nyo nakuha yung changes na ginawa ko. Share ko na lang ulit. All right. Okay, and then we can do the same for MA. Si MA class, ang ano niya, ang model niya is a past error terms. Kaya this one is E T minus 1. This is your error term. Okay, and then usually we use B. Kay AR, A yung ginagamit natin, kay MA, B. But of course, yung iba naman, ibang ginagamit, theta at saka phi yung ginagamit. Okay, so ang ARMA 11 is just the combination of the two. Kino-combine lang natin. So Y sub T is equal to, this is the AR component actually, AR component, and then ito yung MA component. AR component, A sub O plus A sub 1 times Y sub T minus 1, plus the error term, tapos si MA component na naman, itong portion na ito. Okay, so that's what we call an ARIMA process. Ang ARIMA, PDQ, okay, this is also called, by the way, ARIMA. ARIMA din siya. ARIMA, PQ, wala nga lang differencing. Pero ARIMA pa rin siya. In fact, this can be called ARIMA. ARIMA 1. Okay, pag ARIMA 1, ibig sabihin nun, okay, sorry. If, for example, I write here ARIMA 1, okay, automatic yan, ibig sabihin yan, AR process lang yan. Kasi wala namang binigay na yung P component, yung sa MA component. Wala rin differencing. So that's why others will not say ARIMA 1. They will just use AR1. Kasi wala namang MA component, hindi naman din difference yung data. Okay? Alright, clear so far, guys, yung nomenclature natin, yung ARIMA, AR, MA, ARMA, ARIMA, okay? Yung P lags, Q lags, tsaka differencing. Okay, may I check kung clear yon? Okay, good. Good. Alright, so pag nagbabasa ka ng literature, so dapat pag sinabing ARIMA process, alam nyo na yun, ha? Okay, let's continue. Now, how do we model now? Okay, punta na tayo dito sa data natin. Ito guys, yung other materials dito, I will leave you to read that. Kasi na-discuss na naman natin siya before. So what's important is that you can only use the Box-Jenkins approach, yung ARIMA model, if your data is stationary. Ano yung ibig sabihin ng stationary? Stationary means constant in mean, constant in variance. Pag constant in mean, ibig sabihin nun, walang trend yung data, hindi pa taas, hindi pa baba. Pag constant in variance, walang mga volatility clustering. Ibig sabihin ng volatility clustering, there are some points in time where your data goes up consistently or goes down consistently. So for example, I think we showed last time, no? Hindi ko na i-drawing dun sa ano na lang. Dito. Ito, I think this one. Or was it this one? Ito na lang. Control C. Just to have a review. All right. It's very important, stationary in time series analysis. So, dapat yung time series natin stationary bago natin ma-model siya using the Box-Jenkins approach or ARIMA approach. So for example, this one, okay siya, stationary siya in mean. Okay? Pero ito, not stationary in mean. Okay? Ito, non-stationary in mean, stationary in variance. Ano ibig sabihin non-stationary in mean? Meron siyang trend, no? Pataas, tas pababa pa, no? So hindi siya stationary in mean, pero stationary siya in variance. Ibig sabihin, if we will draw this line, no? Hindi naman siya lumalampas sa 95% confidence interval, no? Yung data natin. Unlike this one, tingnan niyo to, no? Dito sa point na to, yung variation ng data natin mataas. Pero pagdating dito, lumiliit na lumiliit. So this is stationary in mean. Ibig sabihin wala siyang trend, pero non-stationary in variance siya. So you have to be very clear about this. You have to understand itong mga yung constancy in mean, constancy in variance, or stationary in mean, stationary in variance. So ito yung tatlong combination, no? Pwedeng stationary in mean, stationary in variance siya. Ito yung talagang stationary time series data. Ito naman, hindi siya stationary in mean kasi may trend siya. Pero yung variance niya, hindi naman parang nagsispread out na ganun. Okay, parang fan. Hindi siya nagsispread out na ganun. Constant lang siya. So stationary siya in variance but not in mean. Ito naman, yung mean Ito lang, oh. Ito yung average niya, eh. Diba? Kahit dito tumataas, no? Dito mataas siya, pero ang average pa rin niya, ito nasa gitna. So this is stationary in mean, wala siyang trend. No? Pero non-stationary invariant siya kasi there are, it's actually a fanning in, ano? Nagpa-fan in siya, papasok siya yung data natin. Okay, so these are very important because, as I said, we cannot model our data if hindi siya stationary. Okay, let's go back to our, okay. Okay, kita nito. This is an ARP process, no? ARP process siya. And by the way, that can be written this one. Hindi ko na diniscuss, pero it can be written as this one. Okay, L means log. Okay, I think I should discuss this. No? So yung y sub t minus 1, it can be written as L. Ano ibig sabihin ng L? Log. Si y sub t minus 1 is equal to L. Okay, si y sub t minus 2 is L2. Okay, si y sub t minus p is LP. Okay, so okay, balikan natin yun, ha? Engage ko lang yung digital pen para masulat ko, para masabi. Okay, kasi baka magulat kayo, may makita kayong mga ganyang nomenclature. Let me just open a Word file. Ang dami nakabukas. Masurado lahat. Okay. So we have here y sub t. Y sub t is equal, what's happening? Y sub t equal y sub t is equal to alpha or A1, A0 plus A1 times y sub t minus 1 plus your error term. Gawin natin plus A sub 2, y sub t minus 2. Ayusin ko lang. So we have y sub t is equal to your constant plus A1, y sub t minus 1 plus A2, y sub t minus 2 plus your error term. Okay. Now this is equal to A sub O plus A sub 1. This can be written as L, log L1 or L plus A sub 2, L sub 2 plus epsilon sub t. Okay? Now, ito mga to, pwede natin ipunta sa kabila. So this will become okay, sandali dapat in-sub t ko na muna. Let me backtrack a bit, no? So if you take a look at this, class, Okay, kulang ako dito. Sorry about that. Okay. Yan. L squared y sub t, L1 y sub t. Ibig sabihin ng log 2 ng y sub t, log 1 ng y sub t. So we can rewrite this as, we can put this to the other side, y sub t minus a1 L y sub t minus a2 L squared y sub t. Yung 2 dito, ibig sabihin log, no? That's equal to a sub o plus epsilon sub t. So factoring out y sub t, okay, we will have 1 minus a1 L minus a2 L L2. Okay, pinactor out natin siya. Y sub t is equal to a sub o plus epsilon sub t. Okay, so this is equivalent to this one. Pareho lang siya, no? Pareho lang siya. Yung 1 minus a1L, a2L squared log 2 to, no? Times y sub t. Okay, so these are equations that's used in time series. So, kasi baka makakita kayo ng ganito. So this is just an AR2 process. AR2 process lang siya, which is just the same as this one. Okay. All right. So let's continue. Pause muna ako. Class, clear ba yon yung log process na yon? I'm sorry kung medyo parang napamadali yata ako. Is this clear? Pa-chat naman please kung clear yung another way to write your P process, no? Okay, good. Okay, so pareho lang naman siya, pinakita ko lang na baka kasi may mabasa kayong ganyan. Bakit may L? L stands for log, no? Log yan. So pareho lang yan, no? No, you can express it this way or you can express it this way. Okay, so we were using the air passengers dataset. I hope you have loaded this. Okay, na-load ko na. So, let me just, di ba sabi natin yung view, hindi ko alam kung bakit naging ganito yung view ng, dati hindi naman ganito eh. I haven't checked kung why when you use the function view, automatically dapat pinapakita niya yung spreadsheet ng AP. Siguro bagong modification to ng R. I'm not sure. Pero so that's why we just kunin na lang natin yung ito AP. So print niya dito yung values ng air passengers. Okay. Si AP guys, it's an object, it's air passengers. Pinalitan lang natin pangalan kasi medyo mahaba yung air passengers na pangalan. Okay, so this is our AP data. Okay, so if you take a look at the structure, it's a time series. Okay, may mga missing values ba? Isum natin yung is and A and none. Wala namang missing values. Frequency niya, 12, which means monthly yung data. Cycle, okay, ito yung cycle niya. Okay, lahat ng January 1, lahat ng December 12. And then summary will just give us a minimum and a maximum. Okay, and the other. Okay, so when we plot this, plot AP, put an X label, Y label, and the label and the main title of the plot. Okay, we have this. I'm going through this quickly because we have discussed this already last meeting. So we can see here that definitely our data is non-stationary. Unang-una, non-constant invariance, diba? May fanning out, no? You can see that this is non-constant invariance. Okay, this one, non-constant variance and also non-constant in mean. So definitely this is a non-stationary data. Our mean is not stationary, our variance is not stationary. Okay, then, okay, this is just an alternative to the plot. Pwede natin gamitin yung GG45 from ggplot2. Okay, you might find the use of ggplot, grammar of graphics, better in terms of features. Okay, so pareho lang naman siya. No? Okay, and then we can create the box plot and makikita natin dito. So this is box plot AP on cycle. Cycle ng AP. Ibig sabihin, di ba yung cycle, it's lahat ng January 1, lahat ng December 12. So it will plot it, gagawa siya ng box plot ng lahat ng January, February hanggang January 1949 hanggang 1960. Ipagsasama-sama niya yun. Tapos December 1949 to 1960, gagawa niya ng box plot. And we have this. And as we can see here, okay, 7 is July. No? We can see here that the maximum ng number of flights, ito yung maximum to eh. No? Wala namang outliers tayo nakikita. No? Okay, July and itong June, July, August. Ito yung medyo matataas, ano? Even September. Okay, these 4 months recorded the highest median, highest in terms of the maximum. Si July yung pinakamataas, and then August, and then followed by June and September. No? Sila yung top 4. Okay, yung medyo pinakamaliit na travel was on November dito, and also January. Sila yung mga fewer travels. Okay. All right, so just a quick explanation of this. I think we discussed this last time. Okay, itong some characteristics or some attributes of our data. Okay, so, and then we learned how to decompose. Right? You can use the decompose function from the stats package to decompose yung object natin na AP. It can either be additive at saka multiplicative. Yung difference ng additive, okay, is this, no? At saka yung multiplicative. Yung series natin y sub t is equal to the trend plus the seasonality plus the random. Ina-add lang siya, additive components. On the other hand, yung multiplicative, y sub t is a function of the trend times the seasonality times the random number. So when we plot this, makikita natin ito yung data natin is this one, and it's i-decompose natin siya yung trend plus the seasonality plus some random value. It's equal to the time series, no? And then here yung multiplicative naman, as we said, it's the trend multiplied by the seasonality factor multiplied by the random. So multiplicative versus additive. Okay, but we're not going to use this function, the multiplicative or additive. Pinakita lang natin na we can decompose the data, because what we're going to use to model our time series is ARIMA. Okay. Now we know that the data is not stationary. Obviously, when we plotted the data, we could see that it was not stationary. Okay, there are several. It would be good to have statistical tests, no? Numerical tests, para malaman natin kung ano nga siya, kung stationary or not. So we have here a statistical test for stationarity. And there are several tests, Lune box, box spears, augmented Dickey-Fuller. So we'll just use this ADF test, augmented Dickey-Fuller test. And it's supposed to test whether our data is stationary. Okay, so we have here, this is coming from the T-series package. And the function is ADF.test. The data that we're going to test is AP. Okay, the alternative hypothesis is that stationary siya. So ang null hypothesis nito, hindi stationary yung data natin. Okay, not stationary yung data natin, null hypothesis. And then usually K, this is the logs. No? You can use 10, usually ang ginagamit 10 or 12 or 16 minsan, yung iba minsan 24. Okay, so tinitingnan nito yung autocorrelation ng data natin hanggang 12 logs. Okay, so let's run this. Okay, so we can see here that the p-value is 0.787, which our conclusion is that we fail to reject the null hypothesis that the time series is not stationary. So this means that indeed we were able to prove via a statistical test that AP, our data is not stationary. Kitang-kita dito, no? Not stationary yung data natin. Okay, meron pang ibang test dito, no? All right. Another way to test it is via using the correlogram. Okay, correlogram using both the ACF autocorrelation function and the partial autocorrelation function. Okay, so dito sa autocorrelation function at saka PACF, ang ginagawa dito is tinetest yung kung correlated ba yung data natin. Kung correlated ba yung data natin for different lags. So kunyari, correlated ba si lag 1? Ibig sabihin yung data points ko ba at time t correlated with time t minus 1? How about yung data natin at time t and time t minus 2? So tinitingnan natin yung correlation ng data natin at a certain time versus a certain lag. No? Okay, so the function to do that is autoplot. So we can use this autoplot and then first the ACF autocorrelation function. It would be good class to also read up on what ACF and PACF does. No? So siguro assignment yun. Understand what are the things that we will learn from an autocorrelation function and the partial autocorrelation function in a correlogram. The plot is called correlogram. Okay, so there are two types of correlograms that we can do. First is your ACF, and the other one is your partial autocorrelation function. So let's first plot yung, sabay na natin siguro. Let's plot this together. Okay. So here we can see, okay, tingnan natin to yung yung unang-una, lag 0, ibig sabihin 1 siya. Ano ibig sabihin nun? It's the correlation between value at time t and value at time t. Kasi lag 0 eh. So obviously, 1 yan. Okay, this one is a correlation, autocorrelation between value at time t and time t minus 1. So we can see here that across several lags, may autocorrelation. May autocorrelation. So when we have this, it means that your data is not stationary. Ganon din dito sa ano. So may sa partial autocorrelation, we can see here significant lags. No? But it's really here in the ACF na makikita natin na hindi stationary yung data natin. Kasi pag stationary siya, dapat may mga walang, ang tawag dito nga pala, it's called slow decay. Dapat hindi slow decay yung autocorrelation function natin. Okay? So, for now, ganun na muna ang tingnan natin As we go along, mas makikita natin class yung significance ng autocorrelation function at saka partial autocorrelation function. So why do we have to plot the autocorrelation function? We plot the autocorrelation function kasi let's say pag stationary na yung data, after we transform the data, tapos stationary na siya, we plot the autocorrelation function para malaman natin kung anong klaseng series ba siya. Is it an AR process or an MA process? Okay, so let me repeat. It's important to do the autocorrelation function and the partial autocorrelation function for a stationary data, okay, so that we will be able to identify what will be the Box-Jenkins model for that. Is it an AR1 process? Is it an MA1 process? Is it an ARIMA process? Okay, so we'll look at this. We'll look at those things as we go along. Okay, so ano ko lang muna to. Alright, dito. Okay. Same plot, ACF and PACF. No? Okay, let's run this. Okay. So, kita natin yung ACF at saka yung PACF. So, although we were able to prove already statistically that the series is not stationary. And just by even looking at the plot, alam natin na hindi stationary. And then there's another powerful package in TSM. No? In TSM, although na-load na natin to kanina, we can use now the AC function, autocorrelation function. Ang kagandahan nitong ACM, itong function na to, is that you don't need to specify ACF at saka PACF. Automatically, ibibigay sa atin yan. There. Magkasama na, no? And side by side pa siya. Right? So, by using the TSM package, yung AC function niya, we can already see the autocorrelation and the partial autocorrelation side by side. Okay. All right. So, alright, dito, check ko lang to. Sa T-series package, let's check natin to. AP. Okay, I have this question. Ini-note ko pa nga, hindi ko pa na-check to. Okay, using the T-series, yeah, I think now we hit a wall here before. ADF dot test. Check na natin itong function na to. From T-series, yan, from T-series. Uses the ADF to test for the null that X has a unit root. Ibig sabihin ng X has a unit root kasi hindi siya stationary. Ayan, time series data is not stationary. Okay. However, when we use this, p-value is 0.01. So we reject the null hypothesis that the series is not stationary. Okay, so I think hindi ko pa nasasagot o hindi ko pa na-research kung bakit yung sa T-series na na ADF test, augmented Dickey-Fuller test, why it's giving us a wrong value. Can we please try this, class? Copy nga natin to. Control C. Kahit dito na lang sa console. Control V. Okay. So ito, nagge-generate tayo ng ng random numbers. R norm 1,000. Siguro para pare-pareho tayo. Okay, let me mag-set that seed tayo, no? Set that seed na 1, 2, 3. Okay. So set that seed 1, 2, 3, and then X is R norm 1,000, and then i-test natin ADF test si X. And then let's run this so that pare-pareho tayo ng values. Run natin. Okay, ito tama, no? Okay. What did I do, guys? So, ang ginawa natin dito, nag-create tayo ng nag-set that seed tayo. Okay, kindly copy this kahit sa console na lang. Control C, chat ko na to para mas mabilis tayo. So that's a function, set that seed, and then we created this object X, which will generate 1,000 random numbers. Okay, i-test natin yung ADF. And it says here that your p-value is 0.01. Okay, p-value is 0.01. So we reject the null hypothesis that your data is not stationary. In fact, nung pinat ko yung data, plot X, ito lumabas. Okay, pause muna ako kasi medyo baka ang bilis ko na magsalita. Okay, chat muna please. Were you able to get the random numbers? Yung ADF test, augmented Dickey-Fuller test, dun sa random numbers na generate natin. 1,000 random numbers using R norm. Normally distributed numbers. Okay, how about the rest? And then try to plot it, class. Tingnan nyo kung ano siya. Random numbers siya, no? So it will generate a 1,000 numbers that are randomized. Tapos wala siyang trend, wala siyang seasonality. So dapat ganito lang yung. Okay, so definitely this is a stationary data series. No? Walang trend, walang seasonality, constant yung variance, constant yung mean. Okay, kindly check please if you were able to do that. Na-generate nyo yung augmented Dickey-Fuller test na stationary siya. Tapos yung pre-nat nyo, nakita nyo naman na talagang talagang not stationary. Stationary siya, sorry. Waiting for the others to please check kung nakuha nyo. Okay. Yeah, good. Thank you. Thank you. All right. Sige. So, yung generate natin, yung random numbers na generate natin, ito, R norm 1,000. We are expecting that this is randomly generated, tapos normally distributed pa siya. So, when we plot it, talagang stationary siya. And the use of the ADF test confirmed na stationary nga yung data natin. Pero ito, si AP, ano siya no? Si AP is not stationary. So, linagay ko pa note na to, no? Check why ADF that test shows AP data to be stationary when it is not. Okay, so let's leave that for a while. Maybe you can help me. You can help me fathom this out. Bakit yung ADF test natin dito, it tells us that the series is not stationary when in fact it's not. No? Okay, diba? Ito, p-value is 0.01. So we reject the null hypothesis na hindi siya stationary. Ang alternative niya is stationary siya. So, pero yung tinest naman natin kanina, yung sa random number, okay naman siya. Alright, so anyway, let's, this one naman, KPSS test. You see, quite, nahirapan ako mag-pronounce ito, quite Koski-Phillips-Mead-Shin test. Okay? Ang null hypothesis na to is that X is stationary. Okay, so you can test here that the null hypothesis is stationary siya at trend or stationary at level. let's run both of this. Okay, here we have a p-value, no, of 0.1. So what does this tell us? Ano ibig sabihin nitong kung ano ba siya, kung stationary siya, null is equal to trend. So we reject that null hypothesis. No? Trend stationary siya. Okay, it's not ano siya, hindi siya trend stationary kasi may trend siya, no? So we reject that null hypothesis. All right, ito naman may isa pa, no? Null is equal to level. So anong sinasabi nito? What does the null hypothesis is equal to level tell us? So again, if you meet questions like this, it's always good to go to the help function. Okay, so let's Control C. Okay, so what I'm illustrating here is that there are several tests for stationarity. Okay, this is also from the T-series package. So ito yung test na yan. Okay, the null hypothesis indicates null hypothesis and must be one of level, which is the default, and then trend. Okay, so ang level is the default. Okay, ano sinasabi niya dito? Level stationary. Okay, so let's try this. Copy natin to. Pero bago natin i-copy, set that seed muna natin ulit, 1, 2, 3. And then saka natin i-copy. Okay. Again, magkakreate tayo dito ng ano. Dapat sana pala yung X na lang. No need to do this. Guys, no need to do this. Kasi may X na tayo eh. So no need to do this. KPSS test na lang. I-test na lang natin yung dating data natin. Si X. Okay. So what does this tell us, guys? KPSS test for level stationary. So the p-value is 0.1. So ano ibig sabihin ng 0.1 na yan? We fail to reject, di ba? We fail to reject the null hypothesis that ang null hypothesis natin is that ano siya? Guys, ano? What's our null hypothesis? Ito, no? Here. Level stationary. Okay, so si X ba, ano? Take note na iba yung ano iba yung null hypothesis kay KPSS. Ang null hypothesis ni KPSS is that level stationary siya or trend stationary depending sa ginagamit natin. Okay, so this one, point P says that we fail to reject the null hypothesis that X is not level stationary. Stationary is X, di ba? Kasi ito yung random numbers natin. Okay, so by the use of the KPSS test, we were able to confirm that indeed our random numbers natin to is level stationary. Okay, unlike here, okay, so dito si AP, no? So magkaiba, guys, yung trend stationary at saka yung level stationary. Okay, bakit magkaiba yung result nila? Kay trend, okay, its p-value is 0.1. So we fail to reject the null hypothesis that our AP series is trend stationary. And dito naman, we reject the null hypothesis that our AP series is level stationary. So what's the difference between trend and level stationary? Plus. Okay, so I will leave you guys to look at this. No? Kindly read up on this. Ano yung difference according to yung T-series na package? Dinidistinguish nila between trend stationarity at saka level stationarity. Okay? So there are yung isa, no, yung sa T-series na ADF test, medyo may problem doon kasi nung tinest natin si AP, which we know to be not stationary, lumalabas na dito sa T-series natin dito, where's that? Here, no? T-series, ADF test, si AP, it turns out that yung null hypothesis natin dito is not stationary yung ano natin, yung AP series. Ang ina-expect natin, we will not reject that null hypothesis. Kasi not stationary talaga si AP. Pero nung rinan natin si augmented decay pooler, no, lumalabas siya na p-value is 0.01, which means that we are rejecting that null hypothesis na hindi stationary yung data natin. Lumalabas ang alternative, which is stationary, is lumalabas na AP is stationary. So, that's why naglagay pa ako ng note dito. No? Why the ADF test show AP data to be stationary when it is not. Okay, sige. So, these are things that you need to know, class. Okay, hindi ko explain sa inyo ngayon yan. Okay, kasi may pagkakaiba yung trend stationary at saka yung level stationary. In fact, kitang-kita dito yan sa result. Okay, let me just show it one more time. Gamitin natin ulit si X. Tapos let's see here, si KPSS. Ito. Okay. Huwag natin isama yung ano. 1, 2, okay. Let's run this. So, ang print lang niya si level stationary. Pero ang pinapaang natin dito pati level at saka si trend. Warning p-value greater than the printed value. Okay. Bakit hindi niya rin pareho? May coach ba dapat to? Hindi niya print yung level. No? Dapat pareho eh. Pero level lang yung print niya. Okay. Pag trend, Okay, so dito sa X natin, it turns out okay siya. No? Whether it's level stationary or trend stationary. No? What does it tell us? Ang p-value natin is parehong 0.1. So, which is correct, no? Because we failed to reject the null hypothesis that the X data is not stationary. So whether we use the level stationarity or the trend stationarity, okay yung ano natin, okay yung KPSS test natin. Ang problema natin dito, class, sa kay AP data natin. Kasi using the trend at saka level, sa trend stationarity, 0.1 siya. No? So we fail to reject the null hypothesis that the data is stationary, no? May trend stationarity siya. Which is what? Which is wrong. Ito naman, level stationarity, we reject the null hypothesis that the data, yung AP data natin, has level stationarity. Ito tama to. Now, why is it may conflict dun sa AP natin? So that's hindi ko pa rin na-check, no? So please help me check that kung bakit si AP dapat hindi siya stationary. Pero when we use the ADF test or even the KPSS test, okay, yung sa trend, nagkakaroon ng error, no? Nagkakaroon ng inconsistency. Okay. Alright. Pause muna ako, guys. Clear ba so far? Isa lang tinitingnan natin, ano, yung AP, no? Tinitingnan natin kung stationary siya, kung stationary data siya. When we plotted it, kitang-kita naman natin na hindi stationary. There were tests that showed that hindi nga siya stationary. Pero nung ginagamit na natin si ADF test, si Augmented Decay Fuller test, ni T-series na package, it's giving us a conflicting result. No? Okay. So far clear ba yon? I hope I'm getting across. No? Clear so far, class? Yeah. Thank you. About the others? All right. Sige. Let's go here. I think we have time to at least consider this question. Kasi sabi natin, pag hindi stationary, hindi natin hindi natin siya pwedeng ma-model. So we first have to convert the series as to be stationary. Okay, how do we do this? We will do transformation. Ita-transform natin series natin. Pag may trend yung series, then we can difference the data. Okay? So pag may trend yung series, pwede natin i-difference. Then, pag na-difference natin siya, usually mawawala yung trend. Okay? If the data contain a trend, first dito, if the time series has a trend, we can difference the data. Ibig sabihin ng difference, ima-minus natin si time t minus time t minus 1. So that means magkakreate tayo ng panibagong time series ngayon. Yung difference na data na, difference sa time series, hindi na yung original. Okay, so ang imo-model natin yung naka-transformed na data. And then later on, after we do the model, tapos mag-prediction tayo, ibabalik lang natin dun sa original. Kasi ang gusto natin i-model yung original eh. But we cannot do that if the time series is not stationary, so we have to do some transformation. Okay? Dito naman, if the data contain a trend, we can fit some type of a curve of the data and then model the residuals from that fit. Okay. So for non-constant variance, pwede ang gagawin natin to take the log or take the square root of the series. Okay, however, pag may negative yung pag may negative yung data natin, hindi natin pwedeng kunin yung log kasi hindi pwedeng i-log yung negative. So ang ginagawa niyan, nagdadagdag muna ng certain constant Okay, kunyari, -1 yung pinakamaliit na negative value. So, pwede ang gawin, dagdagan natin ng 1.1 lahat. Okay, so let me illustrate that. Suppose, yung value natin, yung series natin may -1. Tapos hindi siya stationary, may non-constant siya invariance. So hindi natin pwedeng i-transform yung data by getting the logarithm kasi hindi pwedeng i-log yung negative. Okay, pwede na natin kunin yung logarithm ng mga positive numbers. Hindi rin pwedeng kunin yung log ni 0. So what can be done is hanapin natin yung pinakamaliit na number and then add something to that, a certain constant, a suitable constant to make all the data positive. So kunyari, magdagdag tayo ng very small amount lang, negative. We will add 1.0001. Kunyari lang to If we add 1.001 to our series, ano mangyayari? Yung -1 na to magiging 0.001. Okay, so it will be converted into a positive number. Okay? So we can transform the data by adding a certain constant like this one to your series so that lahat converted into a positive number. Okay, then this constant can be then subtracted from the model to obtain the predicted. Later on na, no? Kung magpre-predict na tayo after we model it. Okay, so what are these transformations? They're intended to generate a series. So mag-generate tayo ng panibagong series na, no? Na ang mean, constant, and variance also. Okay? Although seasonality also violates stationarity, this is usually explicitly incorporated into the time series model. Okay, so ngayon, may seasonality, no? Yung data natin may seasonality. Although this may affect stationarity, usually sinasama pa rin sa time series model yung stationarity. Okay. All right. So pagkatapos na naging stationary yung data, okay, by differencing, the next step is to determine whether AR or MA are needed to correct any autocorrelation that remains in the difference data series. So what does this tell us? Pag naging stationary na yung data natin, ipa-plot na natin si ACF at saka si PACF. Para saan? Para malaman natin kung ang model ba natin na gagamitin is AR or MA. Now, I just want to get ahead of myself. Itong sinasabi ko nito, pa-plot natin ACF at saka PACF. Ito yung long method, ito yung old method. So dati nagta-time series kami, nagmo-model kami. So i-convert muna namin into a stationary data series. Tapos ipa-plot namin yung ACF at saka PACF para malaman kung ano ba to, MA ba to o AR model. Tapos susubukan. So it was more of a trial and error. Kung pinakamaganda ba dyan, AR1, MA1, etc. Pero ngayon, class, the good news is that may mga ano na tayo, may mga softwares, ito, si R, no? Na pwede na nating automatically, you don't even need to plot the AR, the ACF and the PACF para malaman natin kung anong model yun. Okay, so it's almost time, guys. I think I have one last minute. So pakita ko lang to para mag-start lang tayo para next Friday, itutuloy natin from here. So, meron tayong ARIMA.sim function. Itong ginagawa nito is magsa-simulate siya ng series, okay, which can be modeled as an ARIMA. So, dito tayo, set that seed 1, 2, 3, and I'm creating this object called A1. Tapos, ARIMA siya, ang model is AR.8. Ano ibig sabihin nito? Ang model natin is y sub t is equal to a certain constant plus 0.8 times y sub t minus 1. So ito yung A1 natin, 0.8. Ito yung pinapamodel natin. Okay? So 1,000 uh, observations. Run natin to first. Okay, so meron na tayong object na A1, no? Tapos ito yung mga numbers niya, no? Okay? Ito yung first 20 dito sa head. And then i-plot natin to. Okay, as you can see, yung sinimulate natin na object A1, okay. Ano siya? It's stationary, no? It's stationary. Diba? No constant mean, constant variance. Kasi this is an ARIMA 1, AR1, no? AR1 model to. AR1 siya. Okay? And then if we plot the autocorrelation, okay, what do you see? All right, you can see here sa ACF, slow decay, tapos sa PACF, significant lang at lag 1. Okay, so next meeting, okay, we're going to discuss how do we determine kung AR process or MA process. Okay, just to get ahead of myself, to know if it's an AR process, titingnan natin yung PACF, partial autocorrelation. Pag yung partial autocorrelation may significant lag at significant spike at certain lags, AR process yan. Tapos yung ACF mo, slow decay lang. Yan. Slowly decaying over time. Ibig sabihin yung autocorrelation niya at the farther you go from let's say 1, the lower will be the autocorrelation. Tapos may significant spike ka dito. Okay, so let me stop there.